Although hydrophilic and hydrophobic sound similar in name, these substances are quite different with varying characteristics. Terms within the concepts of biology defines hydrophilic as a substance that dissolves in water, where hydrophobic is the opposite in that they do not dissolve in water. Certain substances are considered hydrophilic because they easily form hydrogen bonds with water. Hydrogen, for reference, is known as the simplest element and is one of the first reviewed when studying chemistry or biology and learning about the elements within the periodic table, simply because its atomic number or number of protons, which are positively charged particles within the nucleus, is 1. The main characteristic of a hydrophilic substance is that they are polar covalent compounds, meaning the atoms are shared in a covalent bond due to the electrons, which are negatively charged particles. This ultimately means that they must have either a positive or negative charge. Hydrophilic substances also sit on the surface of proteins, unlike the hydrophobic substance, which sit at the center of proteins. Examples of hydrophilic are sugar, which is a molecule that has 12 atoms of carbon, 22 atoms of hydrogen, and 11 atoms of oxygen. Salt, which is the ionic compound that we know as sodium, that has an atomic number of 11, as well as starch and cellulose, which is a polysaccharide containing several simple sugars stored in plants, and that has 6 atoms of carbon, 10 atoms of hydrogen, and 5 atoms of oxygen. The main characteristic of a hydrophobic substance, on the other hand, is that it is not attracted to water, as they are nonpolar or uncharged compounds, therefore will not dissolve in water. Unlike hydrophobic substances are not able to hydrogen bond, and are mainly made of carbon and hydrogen bonds. Some examples of these substances are oils, fats, and grease. You most likely do not need a science background to have at least heard the saying that water and oil do not mix, meaning that it is any of these substances, including waxes and even steroids, were placed in a beaker of water, they would not only act as a repellent, they would only act as a repellent, as I'm sure most have noticed when a candle melts, that the wax most likely will float as it is less dense than the water. A fun fact in regard to what may affect the strength of a hydrophobic substance is the temperature of that substance, meaning the higher the temperature, the higher the strength, leading to what's known as cold denaturation of proteins, which is when the proteins or nucleic acids lose their natural structure.